Welcome back. So in the last video we saw about independent variables, dependent variables, parameters and order. So now I'm going to tell you some things, to find the solution of the differential equation. So the first thing what we're going to cover is initial condition. We write it as IC. Initial condition is basically something that gives you the value of the dependent variable for a given value of the independent variable. What does this all mean? So for this equation which we covered in the previous video, this is an example of an initial condition. So all it says is the value of u for time is equal to 0 is going to be 100 degrees Celsius. I've defined that u is the temperature. So when we're going to apply it to this problem, it all says that the temperature at time is equal to 0 is going to be 100 degrees Celsius. So all we have now is if this is the body, it's going to be really hot. It's going to be at 100 degrees Celsius and that's going to be at 100 degrees Celsius, of course. And then after a time t, it's just going to get cooled down by convection. And the main problem, or one of the common problems that you might be tested on is after a time of 30 seconds, what might be the temperature of this body? For that, you're going to need to solve the differential equation. So this is how initial conditions work. But then the next one is equilibrium solution. Honestly, this all comes together, How do you find the equilibrium solution? When you're saying something is in equilibrium, it's just static. It's not going to move. In our case, we're going to say that it's going to be, the slope is going to be 0 mathematically, or for this problem, the rate of change of temperature is going to be 0, which just means that du over dt is going to be 0. So when we are saying that du over dt is 0, we are going to get u is equal to t naught. So this is going to be our equilibrium solution for this question. So which means in an equilibrium state, when we are going to say that when there's going to be no rate of change of temperature in our solid body, then we are going to have the temperature of that body is going to be T naught. This is definitely taken in a very short interval of time. It's like telling limit delta t tends to 0. We're taking a very, very, very small time. We say that the slope is almost flat, which is being parallel to the x-axis. And at that time, you're going to say that the temperature of that body is going to be T naught. And of course, when you're going to solve it later on, you'll be knowing that it just be just 100 degrees. But when the time is 0, we say the temperature is 100. So it all means that T naught is equal to 100 degrees Celsius. You would know when you're substituting when you're solving the differential equation. So equilibrium solution, as I just said, is at an instant of time. But what if we need a general solution? It's going to be applicable at all times. So we need to definitely change our value of evaluating it. So when you're going to solve this equation, you have an unknown value for k, and then you don't know t naught if the initial condition is not given, of course. And definitely, since you have a differentiation, you're going to integrate it to get a solution. You know that. And you'll be getting a plus c factor, and you cannot get rid of it. So this is a general solution because there can be different values for plus c, there can be different values for k and t naught. But when you don't know c, there's going to be a lot of changes because sometimes you might have to take the exponentials or logarithms, which I'll be covering in the next video. So that time the c factor just gets multiplied over there. So definitely the value keeps changing for different values of c. The same case happens here. So that is known as a general solution. But usually what we do is we give you certain things like k and normally t naught. But there can be some trick questions where you have to work the other way around. So that's all about the general solution. And so how do you define general solution? Is basically all possible solutions for a differential equation is known as a general solution. Once we know all of this, we can get into what a differential equation actually is and how do you write a differential equation. So there are two types of differential equations. One of them is the linear differential equation and the other one is definitely non-linear equation. So if you see any first order differential equation and which is of this form, then you say it's going to be a linear differential equation. Why is this linear? You can just see because it's of the form mx when you're going to take this to the other side minus c, plus or minus c. So this is of a linear form. So if you're going to have something that's not of this form, like mx square minus c, so you're definitely going to say that's a non-linear equation. In simple words, anything that is not this is going to be a non-linear differential equation. So the homework for this video is take a look at differential equations, check what is going to be linear and what is not going to be linear. And another thing which I wanted to cover is you might come across, like when you're going to look at differential equations, you might come across something of this form, del u over del y, let's say is equal to rho cv t t, or I'm just going to use u just to be consistent, u over dt. These are known as partial differential equations. I would suggest you not to look over this for this instant, and I'll be covering this towards the end of this course. Thanks for watching.